Paul is still up next, but a couple of housekeeping items. We have a coffee service going on at the corner next to the boardroom entrance. So if you feel the need to grab a coffee and come back, please do so. It's running. They'll keep it going on until we close. So we are about, we're half an hour ahead of schedule. So what we'll do is, Sri, are you online? Sri?
Yes. Yeah.
All right, cool. Are you ready to go?
Sure.
All right, cool. So we'll take the next session, which Paul Baker will lead us in bulk payments together with Sri. Then at the break, I will give you an extended break. Don't worry, you will not have to sing to your neighbor. Paul.
Hello, everyone. My name is Sri Miriala. I'm from Infotix. I'm with Infotix from the past 5 years. I've been contributing towards the testing framework from the start. Yeah.
Normally, when we come to a really difficult, detailed understanding of Mojaloop, then we go to Sri because she's dealt with all the edge cases.
Thanks, Paul.
Okay. Hello, everyone. So today I'm going to give you an update on the bulk work stream, just to let you know how far we got. This is a really important work stream, and we've made some pretty good progress, so happy to report on that. So this is Paul Macon's update slide. So we set out with 4 objectives. We wanted to deploy the MVP, and we wanted to then evaluate what was there effectively, and then and then support adopters of it, with the main aim of trying to understand what next we needed to concentrate on. So it turns out that's not really the direction we went in, because we had difficulties with that first one on the deploying of the POC. So we spent most of our time making sure that we had good deployment support inside infrastructure as code and inside payment manager. And while we were at it, we worked on the test cases. We built some of those tests directly into the infrastructure environment, and we then sort of expanded on those test cases because we noticed some shortfalls. Okay, so what we're planning for the next PI. The issues that we came across is distraction from other projects. And I think that is not uncommon here, as it's difficult to find time, people to dedicate onto the project. But despite that, we've made pretty good progress. So pretty happy with the team and the contribution so far. Where we would like to get to is complete those other objectives, and then it would be nice to really tackle the patch notification. I see that as key functionality inside the hub in Mojaloop for bulk. And then there's a CC change control workshop that's really going to be talking about the next phase of bulk API calls. So we would like to participate in that. So why is this bulk case so important? And I must say I'm stealing this from Paul Macon's because I've heard him say this many times before. Is because to support that middle pillar, so it's part of that middle pillar achieving scale, we got to get volumes through on a hub. And to do that, supporting the bulk use case is an obvious way of getting volumes through. It's a difficult use case, and that support would definitely help Mojaloop hub operators. For example, salary payments and social disbursements. So it's an important part. And that in the context of you know, this digital public goods initiative and then other projects also trying to tackle bulk. For Mojaloop to have a really solid bulk solution seems like a really important thing to have at this point. So this is a slide that I shared last time, so this is a bit of a recap. And it's really to emphasize the enhancements that we've been putting in place. So on the left here, we've got a payer DFSP. It's important that this is owned by the payer DFSP. And there we've got this SDK scheme adapter. We're thinking of changing the name. It's not a great name. Think of it as a Mojaloop connector. It's a piece of software that is running on the DFSP's own side that really manages the connections into Mojaloop. And the reason why it's so important is there's automation tools that have been built into that SDK scheme adapter to help onboard the security, and it also ensures that the connection into Mojaloop is done using best practice. So if you use the scheme adapter, you know that you're conforming to the standards within Mojaloop, and that's a big, that cuts out a lot of work. So the way the calls work is we have a bulk disbursement triggered, and then that then does a loop and calls get parties calls using the FSP IOP and really calls a discovery for each of the participants. It then retrieves all those results and then it groups them and batches them in a way for the next phase of the call. So in other words, it makes sure it conforms to the standards which Mojaloop needs to be operated through on the bulk quotes and bulk transfers. So once this grouping has happened, it then asks for confirmation of the parties. So if you're working on a beneficiary management system, you trigger the system off, but then you get back that information so that you can confirm whether the party information being presented is correct. You then say, yes, I'm happy or not happy. You know, you can adjust that message. And then that results in these batches, these post-bulk quotes, and going out into Mojaloop, performing the agreement phase all the way through to the payer DFSP. And then the similar process happens for transfers. Now, you might say, why are we doing it this way? And the reason is, in fact, non-repeatability. And I'm going to touch on it on the next slide. And we haven't really solved all of the non-repeatability questions, and there are workshops going on. But I just want to explain it because it's not always obvious, is that those post-bulk messages can only go to one payer DFSP. And the reason is that message can't be changed because the payer DFSP needs to validate the origin of the message, so it can't be tampered with by the hub. And there's subtle reasons for it, but that's the why this architecture is done. So let me jump to the next slide, which tries to summarize this. So the critical phase is in fact in the quoting phase. So you get a bulk quotes message on the payer DFSP. You sign it using your JWS, which is your personal private key. You then send it through to Mojaloop. On the payer DFSP side, it is the one who's releasing funds, so it's taking on the risk. So it needs to make everything, sure that everything is right and they're happy with everything before they sign the ILP. And part of that is checking that the origin message was not tampered with by anyone and that it came from the payer DFSP. So that's a fundamental sort of concept. I'm just glancing over this. It's really much more complicated than that. But that's the reason why we've got this complicated architecture to support that. And over here, we do have a workshop scheduled so that we can discuss this further and agree on ways forward. Okay, now I'm going to switch over to Shri, and she's going to give you a demonstration of the work that we've done so far. Shri, are you ready to go?
Yes, Paul.
Yeah, go ahead then.
Okay, yeah. Starting with my screen. Hey everyone. Yeah, I introduced myself in the beginning of this session. This is Shri from Infotex. So today, in this demonstration, before going to the what are the enhancements done in this PI, I just quickly want to recap what we have done in the last PI so that I can go over this PI to understand, to better understand the differences. So in the last PI, we have worked on the SDK redesign, where that involves the command event handler and the domain event handler for um, to support the scalability and reliability. And also we have showed a demo using the internal simulators. That means the simulators that are part of the Mojo Loop cluster. Just before Paul mentioned about the JWS and TLS security features, which are not enabled at the time with the internal simulator that are sitting within the same Mojo Loop cluster. And we have demonstrated almost 50 transfers from one sender to two receivers. So this is what we have done. And one second. So along with this, we have also demonstrated some functional tests, which are part of the Helm test as well. So now coming back to this PI, 21 PI enhancements. These are the main differences here. SDK redesign was there last PI and this PI, but using the PM for ML support. So SDK, now the enhanced SDK is part of the PM for ML chart. So whenever we deploy the PM for ML, we get that enhanced SDK version. So that along with the JWS and TLS support, so that is added. And IAC support. This is automation of the deployments, and test automation is also added to the IAC GitLab pipelines. And there are more Helm tests and Slack announcements. The results of these the results of the tests that are running as part of the IAC pipelines that are coming to the Slack channel. And there are more extended tests for this bulk functionality. And of course, there are few new endpoints that are added to the SDK, outbound and inbound, to support the bulk quotes and bulk transfers. So previously we have only bulk transactions. So the payer can trigger only one request which can split into 3 different parties, quotes and transfers calls. But now the payer SDK has the luxury of splitting that request and sending it separately. So those are the main changes from PI 20 to 21. So yeah, this diagram, along with this, I'm sorry, I forgot to mention that. Along with this, the extended tests also include many of the negative test cases, which are part of the CI/CD pipeline and also part of the Helm tests. Now, coming back to the work in PI 21. So this is the diagram that I wanted to show. This is how the external PM for MLs are deployed in an IAC environment. When I say IAC environment, it is a sandbox environment that I'm going to show. And the new endpoints that are added are here. And now SDK is part of the PM for ML on both sender side and the receiver sides. And the small red circle that are showing here are the error cases that we added at a different breakthrough points in different FSPs and in different stages. So to quickly go over at a high level, these error cases are, most of them are from the receiver side. For example, what if the payee FSP partially rejects one of the bulk quotes or the bulk transfers? Or maybe what happens if the timeout from the payee side or maybe purposefully drops some of the transfers in the bulk transaction. So these are all the different types. I spoke about only the one of the receivers, but that can be extended to the other receiver and many other receivers as well. Those were all part of the CI pipeline now, CI/CD pipeline. We implemented all these negative scenarios using TTK, and these tests, I can show where the tests are stored. Now I'm moving on to the GitLab interface here. So this is how the GitLab interface looks like, and sandbox environment. Here we can see different pipelines for deployments and setup or install the internal PM4MLs or the external PM4MLs. And these are all the different jobs that are to run the tests. We have several other tests as well. They're all here. And maintenance of the platform and even the destroy of the platform. These are all the different jobs. I just quickly wanted to show how this GitLab interface is like. The main thing that I want to focus is the three tasks here. One is the run PM4ML TTK test, and the other one is the run TTK bulk test, which is the task 9, and the 10 is run TTK SDK bulk test. So the difference between them, these are all related to the bulk test, but this one is also including the P2P transfer. I will go over it a little bit later, but the main difference between these two are here. The task 9 is the requests that are specifically targeting the switch in a Mojaloop cluster. And this one is, so the requests that are going to hit the Mojaloop services like Mojaloop bulk quotes, Mojaloop bulk transfers, those services. And here, these requests are coming from the SDK, which is from here, I would say. So the job 9 is the requests that hit here directly the switch, and job 10 is the requests that are coming from SDK. Yeah, there is a core connector. We can also extend this to the core connector, but that is something in the future. So yeah, that is the main difference. And as we added the support to the PM4ML, we started adding the test to this to this repository as well here. Okay, now I'm going to trigger this job. It's going to take 1.5 to 2 minutes, and meanwhile, I can quickly show the different error cases. If you go to the GitHub and SDK, Mojaloop SDK scheme adapter, you can quickly take a glance of these different error cases here. The ones in the parties and the ones in quotes errors and transfer errors. Apart from this, as I mentioned earlier, we have added the 2 new endpoints in the SDK to support individually bulk quotes and bulk transfers. Those are also part of these pipelines, but those were stored in a different location at the moment as part of the PM4ML GP. And one more thing that I would like to mention here is, so yeah, the bulk tests are tested from end to end in this as referenced here. We also extended that to test the settlements, the existing settlements model. So we made sure that the existing settlements functionality is successfully able to settle all these transfers in the bulk request. That is a step forward. And whenever this job is complete, whenever this job is complete, you can see the results in the announcements channel on the Slack. My colleague Miguel is going to go over those details in a separate session, which is, I think that is for tomorrow. Yeah. Once this is done, I can download the report. Just trying to see if that is done. I think a few more seconds, maybe. I can show the previous test report here that I downloaded. I think by the time we go over this, that will we can see that complete. So the total test cases that are added to this pipeline here is 18, and we have 195 assertions. All these tests are based on 3 simulators. We have a certain restrictions to use the number of PM for MLs in an environment. So that's why we went with only 3, one the payer and the 2 payees to show the bulk functionality. And when you go into the details, so you can see the different test cases that are part of it. And yeah, if you want to go deep into the different test cases, certainly one can go and take a look here. Those links were already referenced in one of the slides that Paul shared already. So going back here. Yeah, this job is complete. And when you click on that, there is a tab here to download the report. Once you download it, it's it is this one. So the same report was the one that I showed earlier. All the assertions, 195 assertions are successful, 18 tests. And there were a few more that are going to be added. Those are we are in the process of adding them to the pipeline. Yeah. Any questions?
Hello.
Yeah, Paul, are there any questions for the audience that are there, that are present in person?
Yes, we do have a question. Just trying to find a working mic.
Okay.
Hello. One of the problems that we had when we were trying to do testing and we were using Postman to drive all of our tests is Postman often just tests as a service. So you send in a request and you get the response back. So we had to pad a lot of our responses with information that would be presented on the other side of the platform. So for example, in a Mojaloop context, I'm asking to transfer a certain amount of money, and then Mojaloop will communicate with a downstream DFSP to say somebody would like to transfer money. Are you able to test what comes out of the Mojaloop platform on the other side, or are you only able to test responses that you get from the platform's API? Can you intercept messages downstream in your workflow?
Yes.
Did we-
Sorry, Paul, are you going to put this or no?
No, I think it's better if you answer. I can answer too.
Okay. Yeah, there is a test API. Let me go first, Paul. Is that okay?
Yes, please.
Yeah, there is a test API on the Payee FSP side. So we can use that API to onboard the MSISDNs and those kind of stuff that are required for the testing to be successful. So yeah, we can do that.
Great, thank you.
Yeah, there's a lot of different test configurations. If to make sure each of the component works, you've got to really teach each component in isolation, and then sometimes you want them all together and test the end to end. So testing configuration can be complex, but I think that's the really nice thing about the testing toolkit is it's so flexible. You can in fact have a testing toolkit on the other side and connect them together, and they can do their certs through each other, just by the way.
Yeah.
And that's what I meant by generalizing the search engine, to make that sort of more widely available to other mechanisms.
Yeah, so there's a behind-the-scenes link between, so TTKs can talk to TTKs directly as well to synchronize. And one of the reasons we did TTK is because we wanted asynchronous, we had to deal with the asynchronous responses, right, which Postman doesn't do unless you pay for it. So TTK was specifically done to make sure that we could do an asynchronous request and then process the response properly. So yeah,
Yep.
So those things are there for you.
But it does more than that as well, as it can have generic responses based on the input parameters. So you can assign sort of mock rules. And you can also be the man in the middle, so mock rules and then pass them on to another API output.
Yeah, there are certainly a lot of features in TTK UI, so which makes to use TTK, not TTK UI, basically TTK. So which makes us to use TTK in different modes, hub mode, and even you can use on the payer side and payee side, and even as the testing tool. So yeah, definitely we can go over those details in detail if you would like to know. You can ping us on Slack.
One of the big consequences of having a testing environment that can respond asynchronously is your tests run a lot faster. So you don't need to have those delayed waits to wait for the asynchronous response, and then they become unreliable, so you extend those waits out. You have none of that. When you get the result, you respond immediately.
Yeah, and for example, Arion systems, when they want to develop the core connector, so they used the TTK backend on the receiving side, and they were able to test it in their local environment without coming to an environment where Mojalo deployed environment. So yeah, they found it that was very useful. Okay.
Okay, great. Could we go back to the slide deck? Thanks, Shri. I think that demo was really informative, and I particularly like the ISC dashboard because you can understand the level of control that any operational sort of team would have. So I like to see that.
Thanks, Paul. Thanks, everyone.
So I would like to thank the people who contributed this PI. There were more, but I thought I'd just show you the ones that contributed this PI. So there was Kevin, Miguel, myself, Sam, Shri, and Vijay. We all put that effort in to make sure we got it over the line. So thanks, team. And the next slide. Oh, I'm pointing the wrong way again. There we go. Future roadmap. So what I want to do here is illustrate that we're very far from complete. we got an MVP, we got something that can work, which is fantastic. But sometimes you want it to have a few more features, bells and whistles, and we've listed them down below there. Some of them are small, some of them are big, and we're really calling out to the community to get involved. You know, this is a good team. We do some solid work. Join us. You know, participate with us, and we can help get some of these line items off done. So big call out to the community. To summarize what I think we're going to be doing next is we got on the FSP IOP side, we got enable patch notification, maybe a bulk discovery. There's some performance things we'd like to get our heads around, and then PISP bulk. UI support, we've got bulk transfers. A dashboard would be great, you know, so you can actually see that from inside the hub. Then on the DFSP connection support, you know, there's a list of things that we can add quite simply to complete the original design. Some auto acceptance of parties. There's a set of rules that need to happen for that, and the same with the quote, limits and fees and currencies. None of these things are rocket scientists. You know, it's something that there's somebody who's interested in this use case and is interested in contributing to the community. This is a great place to start. And then if your preference is UI, then there's some UI needs requirements on the DFSP side as well, and etc. And then training and hackathons and people getting used to this use case. All of that effort would be appreciated. Thanks. So then any questions before we end this? Go to break.
Hey, Paul, can you hear me?
Yes, I can hear you.
Yeah, it's Miguel here. Just to clarify something on what you mentioned about the TTK. So our GP, the Moduloop GP test that we ran when we're using Postman took 15 to 20 minutes. And when we switched to the TTK, it took 2 to 3 minutes. And that was purely because the TTK is able to understand how to handle async requests. And, and where Postman would actually do things via polling methodology. Sorry, just thought it would be worthwhile saying that.
I wanted to say that, but I couldn't remember the numbers. So
Yeah.
Thanks, Miguel.
Just to, someone asked, what is a Moduloop GP test? So those are our golden path tests. So those are the tests that we package as part of a Moduloop release. And we use those tests to validate the core services, basically. Thanks.
Great. Are there any more questions? Okay, thanks everyone. Let's go and grab some coffee.